welcome to section 12.4, Properties of Logarithms. Hopefully by the end of this, you all will be able to use properties of logarithms to expand and condense logarithms. So we've got 3 properties of logs, and that's it, okay? And logarithms in general, if you remember how we could rewrite things in exponential form, logarithms act a lot like exponents, and so these properties are hopefully going to remind you a bit of exponent properties. So the first property we have is called the product property. So if you have the log base a of x times y, you can separate those into the log base a of x plus the log base a of y. Hopefully that reminds you of, hey, if I have 2 things that have the same base and they're multiplied together, I add those exponents. Hopefully it kind of reminds you of that a little bit. The quotient property, if you have the log base a of x divided by y, you can kind of separate those out into log base a of x minus log base a of y. And again, hopefully that reminds you a little of those exponent properties where if you have a base raised to an exponent, divided by the same base raised to an exponent, you had that division. What you did was subtract the exponent. So hopefully it reminds you a little bit of that. The last one we have is the power property. So that's log base a of x to the r. So we have something raised to an exponent. What you can do is take that exponent and multiply it by the whole logarithm. So we would do r times log base a of x. And again, hopefully this reminds you of exponent properties. If you have a power raised to a power, you would multiply those together. So you're multiplying that exponent of r times the log base a of x. So the first thing we're going to do is just practice expanding. So we're going to start with one logarithm and we're going to kind of expand them out, and you'll see how sometimes it's easier to simplify the things this way. Okay? So example 1, the first one I have is the log base 6 of 36x. So that's 36 times x. I'm going to use that product property to separate things out. So this is the log base 6 of 36. That's the first thing. And we're going to add the log base 6 of x. We're going to use that product property to separate these out with addition. From here, you might see, hey, wait a second, 36 is a power of 6, isn't it? So 6 to what power gives you 36? Well, 6 squared is 36, right? So the log base 6 of 36 could actually be simplified down because the log base 6 of 36 equals that exponent, which is 2. So we could actually simplify that to be 2 plus log base 6 of x. All right, let's look at another one. We've got the log base 10 of 10 to the x. Kind of like putting parentheses, so I realize like what all is inside of the logarithm. So this one we have something raised to an exponent, so I'm going to use that power property. Okay, so the power property tells me that I can take that exponent and kind of move it out front and multiply it by the logarithm. So this is going to be x times the log base 10 of 10. So using that power property a bit. And I can actually do the log base 10 of 10 if I think 10 to what power gives me 10? Well, 10 to the first power is 10, right? So the log base 10 of 10 is 1. So really I have x times 1, which would be x. And so you can see how expanding first helped me to simplify this logarithm. All right, and C looks nice and fun, doesn't it? We have, all kinds of variables and numbers and all sorts of stuff going on in part C. So maybe not so much simplifying, but we can do a lot of expanding. We've got the log base 3 of the cube root of 5 over k squared times t. All right, so we've got a lot of things going on here. We've got division, we've got multiplication down here, we've got exponents, so lots of stuff going on, okay? So how about we just deal with the division first, okay? So I'm just going to separate things out. This would be the log base 3 of the cube root of 5, and then we're dividing by the k squared and we're dividing by the t. So we could do minus log base 3 of k squared. I'm just separating each thing that I possibly can. And I'm going to do a minus log base 3 of t. And you're going to say, well, the k squared and the t are multiplied together. I hear you, but they're both in the denominator. So we're dividing by k squared and we're dividing by t. Okay? If you want to do like a plus and do them both in parentheses and then distribute, I suppose you can, but we'd end up in the same place. Okay? Now I need to deal with my exponents. If you remember, when we have a cube root or any kind of root, you can write those as rational exponents. So the cube root of 5 could be rewritten as 5 to the 1/3 power, right? So then I've got this power inside my logarithm, and we can use the power property to put that exponent out front and multiply it by the logarithm. So this would be 1/3 times the log base 3 of 5 minus. In this next one, we have an exponent of 2. We can also use our power property here. So I'm going to move my 2 up front. I'm going to multiply 2 times the log base 3 of k. And then this one, I mean, there's not much more I can do to t. So it just kind of is what it is, minus log base 3 of t. And that is the expanded form for this one. Nothing really simplified, but it is a good idea to be able to expand these. Now it's your turn. You guys get to try one and show me how much you've learned.